Holiday and Resnick, Chapter 7, Problem 30. A block of mass lies on a horizontal, frictionless surface and is attached to one end of a horizontal spring of constant K, whose other end is fixed. The block is initially at rest at the position where the spring is unstretched. When a constant horizontal force F in the positive direction of the x-axis is applied to it, a plot of the resulting kinetic energy of the block versus its position x is shown. The scale of the figure vertical axis is set to 4 joules. What is the magnitude of F? What is the value of K? I want to redraw this just a little so you can see what's going on. We're going to stretch this spring 1 centimeter. I believe that's 1 meter. And this is the stretch position. Then we're going to release it. And it's going to travel. It's going to go to 0. 0 is the position of the spring in its relaxed position. That's if the spring was just laid out on the table. It would be, when it reached 0, it would be at the length it would be in its relaxed position. And also, 0 at this point is the highest kinetic energy it would have. It would be at its max kinetic energy, which is 1/2 mv squared. Then the spring will travel, still stretching, till it reach 1 again, 1 meter again. Then it will turn around, come up through 0, and that would be a full cycle. This is a cosine function. If you look at it, this is a cosine function. So we know when it's stretched, all the kinetic energy is potential. So we got potential energy at this point. And at this point, it's all kinetic energy when it swings through 0. And at this point, where it's getting ready to turn around, it's all kinetic energy again. So what we have here is 1/2 of a cycle, of the cosine cycle. So we know to solve this, it says, what is the magnitude of F? Well, the potential of a spring is equal to 1/2 K x squared. So K, since we need K in order to get the magnitude of F, this will go to K is equal to 2 times the potential energy divided by x squared. And will be 2. Now the potential energy is 40. It is the same energy as the kinetic energy at its max, which would be 1/2 mv squared. but the potential energy is 4.0 joules. So 4.0 joules divided by x squared is only stretch 1 meter, so that's 1, and that will give me 8 Newton meters. That's that's K. K is equal to 8 Newton meters. Now the force, we're just gonna for the magnitude of the force is just gonna be F equals minus KX, and which is just going to be 8 Newton meters times, it's only stretch 1 meter, 1 meter, meters will cancel. So the magnitude of the force will be just 8 newtons. So this was a fairly easy problem, but let me just write out the function for this. This would have been A cosine omega t, and in this case, A was 1, so we have cosine, and omega is the square root of K over M times T, just to make it a little more interesting. Okay.